Good day, everyone. I welcome you to another episode of Simplified Chemistry for Waec and Jamb students. In this particular video, we're talking about the atomic theory. The atomic theory was proposed by John Dalton in 1808. He was the one that proposed the atomic theory. And the atomic theory usually refers to as the Dalton's atomic what? Atomic theory. And he proposed 5 theories. The first one states that all elements are made up of small indivisible particles called atoms. According to him, every element you see, the smallest particle you can get from every element is called what? Atom. For example, now hydrogen, the smallest part of hydrogen is called atom. The smallest part of helium, anything at all you can think of that is called an element, the smallest thing you can get from it is called what? An atom. And according to him, if this is an atom, you can neither destroy it, you can't create it. So atom, according to him, atom can neither be created nor what? Nor destroyed. So this was the second theory, that every atom, that smallest particle that is made up of an element, can neither be created nor destroyed. Then for the third one, he said atoms of same element are alike in every aspect. Atom of hydrogen is alike in every, no matter how you do it, is the same, and is different from atom of helium. Atom of helium is differs from atom of lithium, differs from atom of beryllium. That was according to what he said. Then the next one, atom combine in small ratio. For example, water, what is the ratio here? 2:1. Example again, carbon 2 oxide, what's the ratio? 1:1. According to him, that atom combine in what? In small ratio. They combine in small ratio. Then last one, all chemical change results from the combination or separation of atom. You already know what a chemical change is. According to my previous video, I said the chemical change is that kind of change that is not easily reversible. And according to John Dalton, he said those reactions are not easily reversible. They result from the combination or the separation of what? Of atom. But from what I've explained so far, do you think what John Dalton proposed is true? No, it is not true. That led us to the modification of Dalton's atomic theory. The first law states that, or the first theory said that all elements are made up of small indivisible particles. But Ernest Rutherford was the one that bombarded the nucleus of an atom, and 3 subatomic particles were gotten. We have the proton, we have the electron, and we have the what? The neutron. Like what I will always say, I will draw a structure like this. Let me make it more clearer. Then we call this the nucleus of an atom. Okay, let me first label the major thing. The one that is positively charged is called the proton. We have one that is neutral here, which is called the what? The neutron. And the electron, which is negatively charged, revolve around the nucleus. So this is called the what? The electron. And all of them, before then, these two, they are found in the nucleus of the atom. And all of them, they are found in the what? In the atom. So according to Rutherford, or according to what John Dalton said, he said the smallest particle of an element is called what? Atom. But when atom was bombarded, we got electron, proton, and neutron, which is going against what? The first atomic theory. So, and this law was disproved by what we call what? Radioactivity. Radioactivity. So this was all that we used to break the first law. The second law states an atom cannot be created, not destroyed. An atom can neither be created, not destroyed. Is it true that atom can be created? Is it true that atom cannot be destroyed? Atom can actually be created, and atom can actually be what? Be destroyed. And radioactivity can as well be used, but we are going to use law of mass action or conservation of mass. Conservation of mass, or still on radioactivity. We can create atom, and we can as well destroy what? Atom. Like what I showed you here now, this is destruction of an atom. An atom can actually be created. For example, in radioactivity, uranium 238, here is 92, can be created, can be used to create thorium 234, and here's what, 90, then an alpha particle will be what, will be emitted. So the second law was disproved using what, radioactivity as well. The third one, atoms of same element are alike in every aspect and differs from atoms of other elements. Let's go to isotopy. Let's go to all the isotopes. Now, what they are trying to say is that the neutron number of hydrogen, the neutron, the proton, the electron number of hydrogen differs from every other element, which is not true. Because we already know that there are some situations whereby we believe that we have isotope, two different elements that have the same proton number, isotopes, two elements that have the same proton number. So it can actually be what? Be contravened. Then the next one we have here, atoms combine with other atoms in simple ratio, like what I told you the other time for water. Now, if you have iron oxide, this is not in simple ratio, including other organic, this is 3:4. We have other organic compounds. Other organic compounds are very, very broad, very, very broad, that they never combine in what? In simple ratio. So it was conserved by organic compound and the rest. That was how the whole Dalton's atomic theory was modified. And what I just explained now is the modification of Dalton's atomic theory. The first one, atoms are actually divisible, which is the proton, electron, and the neutron. Then atom can be created and atom can be what? Destroyed using radioactivity. The atom of same element can be alike, but most cases they differ. That's why we have your, it's not a must, it must be alike. It's not a must to be alike. It can be. That's why we have the isotope, isotone, isobars, and the rest. The atom can combine in simple ratio, which also a lie. Atom can combine in simple ratio and also in whole numbers. Yes. Then all chemical change result from the combination and separation of what? Of atom. So that is the atomic theory. If you have any question based on what I've explained so far, what are you waiting for? Ask your question. I'll be waiting for you. I hope to see you in the next episode, but for now, goodbye.